Thanks, Jim. This seems a good time to get our audience involved. I've been handed several questions that people have asked online, but before we go to those, I want to report on the polling results from that first question, which asked, what's the most important thing that we can do to help students master algebra? 33% of you said put its study more consistently in a real-world context. 30% responded ensure that students have the prerequisite skills and knowledge. 16% said ensure that teachers have a deep knowledge of mathematics. 18% said ensure that the curriculum allows for depth, not just breadth. And 2 responded other. I want to thank everyone for responding, and be sure to finish the rest of those polling questions if you have not already. Now, on to the questions from those of you that are viewing. I have actually a group here that all are kind of around the same topic. This one comes from a district administrator up in Maine, and it has to do with this issue of accelerating students, middle school students, into algebra. And I wanted to get your reactions about that. Obviously, again, lots of people have an interest in that. I'd be curious to hear what you on the panel think about that issue and how it affects, I guess, further math study, too. Jim, do you want to start?
Okay, yes.
Okay.
Well, I think we probably all here on the panel agree that the starting the study of algebra should be when the students are ready. It's not a switch that is just time dependent. I think it requires every district and every school to do a careful analysis of, again, what information is necessary to be ready, and then making sure the students have those skills in order to be successful. We certainly don't want to start students who are not ready into an algebra experience where they will be unsuccessful.
And I think that if we're going to move them down, I think you have to look back, as we've talked about all day, about what's happening in elementary school, how have we given them these skills, and you almost need to start. If your plan is to roll back algebra into an earlier grade, then you need to start that at really earlier grades, so that by the time they reach 7th or 8th grade, then they're ready, or at least you have something to base individual students. Is this student ready? Yes. This student ready? Not yet. But they've had the opportunity to demonstrate that they've got these skills, and those that have demonstrated it should go on. Those who have not demonstrated it, it's not their time yet. And I think that to come up with, and I know there's a great deal of pressure a lot of times to have a certain number of students, a certain percentage and stuff, to come up with an arbitrary number for any class of students, I think is necessarily unfair to the students. I think you need to take each group as they come along. You may find a group that's got 90% of the 7th graders ready to go. Well, that's great. You may find you have 9%. And whatever it may happen to be with that group, based upon what you have given them as a basis from earlier grades, that's who should be taking algebra, and no one else.
Because it does involve more than a change in enrollment patterns. Our district does have the goal that we wanted all students to be able to complete algebra by the end of 8th grade. And we had set a target, a benchmark of 5 years, making sure that we could transition into that in terms of looking at the curriculum, the kind of support that we provided for our students as well as for our teachers. And we looked at our data on our statewide performance assessment, and we realized that we weren't there. So it didn't make sense to enact the goal and say, this is the drop-dead year, this is when we're going to do it, when we knew that some of our students did not have the prerequisite skills to be successful. So as a result, what we did was we set a timetable and a benchmark for a good percentage at 8th grade, and then looking at 100% at grade 9. But simultaneously, you can't just put all of your eggs in one basket looking at Algebra 1. You've also got to make sure that you have courses available for students beyond Algebra 1. What's going to happen to those students that take calculus or another math class as a junior and they feel that they finished, and then their senior year is there when they should still be in mathematics. So you want to look at what do you have available for students beyond Algebra 1? Do you have some really good courses that would be preparatory courses for college or for a trade school? What do you have available for students above the level of Algebra 1 completely? So it's looking both ways, beyond and before.
Interesting. Great. Thank you very much, Denise.
Go ahead, Mike. I was going to say, and there is an upside. I hope I didn't sound too negative that we were pushing kids in that didn't belong, but I think there's also an upside to this. When you do set your sights that high, I think that there are students who may at some point of at one time fallen between the cracks that would not have been pushed into algebra that can do it, and now they'll have that opportunity, which they might not have had before. So, there's good and bad in any situation.
Thank you, Mike. We have one last pre-taped segment focused on what John Starr calls problem-solving flexibility within representations. We've talked about between representations up to now. Let's hear what John and his research have to say about within representations.
So let's say we want to think about solving a linear equation and what it looks like to know more than one way of solving an equation. So here's a typical linear equation. If I gave that to my students in an Algebra 1 class, then most people would solve it a certain way. They would first use the distributive property to get that, and then they would subtract 3 from both sides, and then they would divide both sides by 3. So that's a perfectly legitimate, reasonable way to solve equations. In fact, this is the way that many textbooks teach as the way, the best way, the only way, in some cases, to solve equations. It works quite well. It's reasonably efficient. It works for pretty much all linear equations. But it's not the only way to solve equations. If I took the exact same equation, I could think about a very different way to solve it. If you look at this different way, you'll see that arguably it's better. This took me only 2 steps to complete, and this took me 3 steps to complete. So the point here is not that students should always use the absolute best way, that we need to drill it into them. For this problem, here's the best way. For this problem, here's the best way. The point is that understanding in algebra with this within representational fluency means knowing more than one way and knowing when to use those ways in certain situations. Why is that important? We sometimes think we're making our students' lives easier by only focusing on one way. We say, they're having such a hard time with this, I'm just going to make this way as simple as possible, do these steps in this order, that's how you solve all problems like this. I'm going to make things as simple as possible for you. But I would argue that that's actually not serving our purposes that well. If a student only knows one way, and they've just memorized a series of steps to do, then if they get a little confused down the road and forget one of those steps, or if I give them a problem that looks a little different than what they've seen before, they're stuck. They've got nothing. They don't remember any way to proceed. And in fact, people would say that's where our students are now. They were taught one way, they memorized that way, they forgot that way, and now they can't complete any of these problems. But think of the alternative. What if a student knew multiple ways, some of which were more intuitive, some of which were more formal, they developed some understanding about these different ways and how and when they were used? Then if I see a problem that looks very strange to me and it doesn't seem to fit with this one way that I know, well, I've got this other way to know that I can use. It's sort of like putting extra tools in their toolboxes. Why should they have a toolbox that only has one way in it, even if they're really good at using that one way? It seems like flexibility involves knowing more than one way, and certainly experts do. This focus is turning that on its head a little bit, and it's saying that I'm as interested in the process students go through as I am in the product. So students will say, well, what's the big deal? They both get the right answer. Aren't we just trying to get the right answer? And my response would be, no, that's not what I'm interested in, is you getting the right answer. I'm interested in you understanding what you're doing. And understanding what you're doing for me means knowing that there are multiple ways and that there are different processes and different strengths for different problems of those processes.